Hi everybody, welcome to another video. This one is about multiplying and dividing radicals. Before we jump into some examples, and I do have quite a number of them, I want to first run you through some points to remember. So some rules about radicals when you're multiplying and dividing. The first rule when you're multiplying is that, and I'm looking over here, the first rule is that when you multiply radicals and there are two of a kind, what happens is that you get an expression with a power of 2. Now, a power of 2 has the ability to negate or cancel out a radical. So as you can see over here, when these two multiply with each other, what happens is that you get a radical a squared. Now this a squared, this squared over here, has the ability to cancel out the radical, and what you get is just the radicand, which is just the a inside. It comes out and it's free. There's nothing left on it. When you're dividing radicals, it's pretty much the same idea as when you're multiplying, except there's this slightly different rule when you divide that we have to keep in mind, and that is that we can never have the denominator be a 0, and the reason is because it would make the fraction undefined. Not only that, but when you have a fraction with two radicals like over here, radical b over radical a, you could, if it's convenient and it would make the work easier, write the whole thing under one radical instead of having them separated. Now, the only time that you might want to do this is if you can reduce. So if, for example, you have a case like radical 6 over radical 3. Well, in algebra, radicals should never be left in the denominator. Now, we could rationalize the denominator, which is getting rid of the radical over the 3, or we could just notice that 6 and 3 can both be combined. And it's safe to do so because both numbers are inside a radical, and the radical is of the same order. So I could rewrite this as simply radical 6 over 3, do the division inside the radical, and I would get radical 2. Okay, so that's an example of that. But let's go ahead and jump into our examples down here, which I prepared for you. So example 1, when you multiply radicals. Okay, so these radicals are the same order. They're both square roots. All you have to do is combine them into one radical sign. Now, it might help to always first see if you can pull out a perfect square, or if you have a perfect square to begin with. So let me do a quick analysis here. Radical 3, not a perfect square. Radical 2, also not a perfect square. And because these are both prime numbers, splitting them will only give me the same thing I already have. So what I do is simply multiply it together, and that simply involves putting radicals 3 and 2 under one radical sign, and then I get radical 6. And and that would be my answer. Okay? In example 2, I could do the same thing I did in example 1, which is just go ahead, put 3 and 6 under one radical sign, multiply it together, and then see if I can reduce or simplify. Or I could notice that, you know what, this 6, if I were to split it into two factors, one of them would give me a radical 3. And multiplying radicals involves a bit of strategy, kind of like playing a game. You have to think a step or two ahead before you make your move. So I will keep this radical 3 here, but I will split this radical 6 into a radical 3 and a radical 2. And the only reason I want to do this is because I know ahead of time that I can get two of a kind over here. And as you remember from the rule, when you have two of a kind, the radical disappears. And as you can see right now, this produces a radical 3 squared, that dot should be higher, times radical 2. And this square negates the radical sign. Okay, they eliminate each other. They are exact opposites of each other. And so what I get is now just 3 radical 2. Again, that radical 2 is not going anywhere. It's irrational. I cannot do anything, so I leave it there. Okay? Example 3. In example 3, I have coefficients outside. So I have this 4 over here, and I have this 5 over there. And so what I want to do is group them together by type. So 4 times 5. And then I also have radical x times radical x to the third power. Now, actually, you know what I'm going to do? I'll do it in the next step. What I'm going to do is multiply each group together and see what I get. Okay, so I have from 4 times 5, I get 20. From these two radicals, I get x to the fourth power. Now, there are different ways to approach this. This is one way, so I'll stick to this one way. X to the fourth power. Now, remember, only a power of 2 has the ability to cancel out a radical sign with an order of 2, okay, a square root. So if I have a power that is higher than a power of 2, what I want to do is I want to see how many powers of 2 I can take from that. So this is a question of division, and I know that I can pull 2 radical 2's from this. In other words, I can split this into 2 separate radicals where each has a power of 2 inside it. And remember, from the law of exponents, when powers add together, you create a new one. So this 2 plus 2 would make the 4 that I have over here. And so it's safe to do this. Now, because these two cancel out, what I'm left with is 20 times the x that came out of here times the x that came out of there. And because x times x is simply x squared, I have a final answer of 20x squared. And that's example 3. Okay? Remember, whenever you have higher powers inside and you're dealing with a square root sign, try to see how many powers of 2 you can pull out of there. It's simply a matter of dividing in your head. All right. Now on to example 4. Examples 4 and 5 have to do with dividing radicals. And whenever you have a radical in the denominator, you have to see if it's a perfect square. And if it is, remove the number. If it's not a perfect square and the number is stuck inside, you have to do something else. Oops. So going ahead with this, only a radical times another radical of the same exact kind creates a power of 2. When you have 2 of a kind, you get that exponent of 2 inside, and that exponent of 2 has the power or the ability to wipe out that radical sign. Okay, after which you would just get the a. So that's my goal here. My goal is to see if I can remove that radical from the denominator, and I can by simply creating another radical made up of the same thing. So when you have 2 of a kind, that radical is going to disappear. My 3 will come out. But the thing is, whenever you do something to a denominator, you usually have to do the same thing to the numerator because it's a package deal. A fraction is comprised of 2 numbers, one in the numerator and denominator. So if you affect one, you're automatically affecting the other. So you have to represent that, which is why I put 2 radical 3's like this. And when you multiply fractions together, you do it at eye level. So numerator times numerator, denominator times denominator. And going ahead with this, what I get is, I'm going to erase this over here. What I get is radical 8 times radical 3. And then in my denominator, I have 2 times radical 3 to the second power. Now, you might be wondering at this point, well, why didn't he simplify that radical 8? Or why didn't he multiply the radical 8 and radical 3? There's a reason for that. And the reason is because I want to first eliminate the radical from the denominator, so I don't have to think about that later on. Okay, so this power and that radical eliminate. What I have now is a denominator of 2 times 3, which is going to be 6. Now I can focus on the numerator and see what happens. So in the numerator, I have a radical 8. Now radical 8 can be divided into 2 factors, and those factors would be radical 4 times radical 2. Now if you notice, radical 4 is a perfect square, so that's good news for me. So this radical 4 becomes a 2. The radicals 2 and 3 are each prime numbers, and they are not going anywhere. So if I combine them, I get a number that is also not going anywhere. It's irrational. Okay, now one thing to keep in mind here at this point is you cannot do this. You cannot remove those two sixes from that fraction. And the reason is because this 6 here is locked within the radical sign, and this 6 is not. Okay, now if you were to use a calculator and figure out the value of radical 6, it would be completely different from just a whole number 6, which is another reason why you should never just divide these out. Okay, I know it's tempting, but that would be a mistake. What you do instead is you focus on the numbers that are outside. In this case, that would be the 2 here and the 6 here. Neither of them are covered by a radical, so you're free to reduce those two numbers as if you simply had a fraction of 2 over 6. And so if you reduce those, what we get is radical 6 over 3. And that would be my answer. All right, let's move on to our last example, example 5. In example 5, I have, as I said earlier, a fraction contained within an entire radical sign. Now, the way to do this is you can do it in two ways. What I'm going to do is first see if I can reduce that fraction inside before I divide them into having each one having a radical sign. And I know if I were to divide each one by a 5, what happens is I get a nicer radical to look at. So this would be 2 over 3. Now I can split this up, so it's radical 2 over radical 3. And now I can deal with this radical in the denominator by eliminating it like this. Again, you multiply side to side. What you would get is radical 6 in the numerator, and you would get radical 3 squared in the denominator. And because a square cancels a square root, this eliminates with this, and what I get is radical 6 over 3. Again, the 6 and 3 cannot be reduced because one is inside a radical and the other is not. So that would be the end. All right, example 6. Actually, this is my final example. In example 6, we have variables. Now, when you deal with variables, the principles are the same as when you work with numbers. Okay, so what I'm going to do is first see if I have an opportunity to pull anything out. I'm going to do this by first splitting these up. Okay, I see that there's a y down here, so that's why I want to split this up over here. In my denominator, I have this times this times this. And right away, what I see is, oh, I can divide those and they eliminate right away. Okay, so when they're gone, I have less to think about. This power of 2 and this radical, they both cancel out. And with that, my work just became a whole lot easier. So now I have x radical 3 over 5x. Okay, this x came out of here. Now, whatever's outside a radical is not covered by a radical. It's free to be reduced. And I see that I have an x here and an x over here, and neither of them are covered by a radical. That means that they are vulnerable. And I can eliminate them, I can eliminate them by division. They cancel out. And what I'm left with as a final answer is radical 3 over 5. And that's it. Something that looked complicated at first actually turned out to be one of the easier examples out of them all. So I hope this video helped you out. Multiplication and division work by the same principles, more or less. So if you understand how to multiply, you have a pretty good shot at being good at division. Stop by and leave a comment if you so desire. And as always, thanks for taking the time to watch. Take care. Bye.